Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 19 of a unit motion in a straight line. In today's class we are going to discuss about the previous year asked questions. This is part 2 of this series, previous year asked questions. In the previous session we have discussed the questions that have been asked in medical examinations. Today we are going to discuss about the questions that have been asked and they are having an even higher probability to be asked in engineering examinations. So let's do it quickly. Have your pen, have your paper with you guys and do it with me. Make it fast. Let's begin. Go through the data. Go through it. Make it possible. What they have said is a man is throwing balls in air. Yes, this is the question of juggler. He throws a next ball when previous one is at the highest point. Okay, if he throws each ball after 2 seconds, then height to which this ball rises, that this is the situation, that this is the first ball and this would be the second, and he throws next ball when previous one is at the highest point. If he throws the ball after 2 seconds, so this time would be at 2 seconds. So even if it's a time of ascent is 2 seconds, then time of descent, this is time of descent, that must be 2 seconds. What you need to find out, you need to find out the height to which ball rise. It's a time of ascent is given, time of descent is given. So what I can have is h is equals to half gt square. H is equals to half gt square. If I replace the value, they have even given a freedom to g is equals to 10. So that would be equals to 1 by 2 into 10 multiplied by 2 square. It's a 1 by 2 into 4. It's a 10 into 4 divided by 2. It's a 20 meter. So this would be the answer. Yes, it is a question of 20-30 seconds. I hope these things are clear to you. Is it? Is it? Okay. Shall I add something? Shall I? If they ask that in the previous question, find out velocity of projection of each ball, with what velocity he must be throwing this ball into air so that this can be happen. So look at this, this was the situation and this time required was 2 seconds. So I know that this is the maximum height and at this height this velocity would be a 0. So what I can have is v is equals to u minus gt. This is the initial velocity u with which he must be throwing it. This is 0. U I required minus of g is the 2 and time of ascent it's 2 seconds. So if I solve this, it's a u is equals to 20 meter per second. This is the initial velocity. U is equals to 20 meter per second. I hope these things are clear to you. So this kind of questions are basically a questions of juggler can be done. Yes? Are you sure? Can it be? Okay. So let's move to the next question quickly. Look at the data, what he has given. What he said is that a body is projected vertically upward at time t is equals to 0 and it is sent at a height h at time t1 and t2 seconds during its flight. That means it is at same height, at two different instants of its journey, and that height is given as an h. The maximum height attained by it is. So first have a rough sketch of it, that what they are asking, that let's say this is the object that has been thrown into the air and it has been available at this point. Now what they say is that it is sent at a height h at time t1 and t2 second during its time of flight. So what I can have is, let's say that this is the height h at which it is available at two time. One of the time it's a t1 and another time from here to here. Yes, this is the time t2. Yes, if you remember this kind of questions, we already did this kind of question in our the classes of the motion under gravity. Yes, so this is t2. If it is t2, this, and this is t1. If this is t1, even this can be said as a t1. So if I considered what would be the time of flight, time of flight would be equals to this t2 plus t1. So this is t2 plus t1. Now I know that time of flight is equals to 2u by g. So what I can write is, it's a 2u by g, that should be is equals to t1 plus t2. What I require? I require a maximum height attained by an object. I am interested in the maximum height. So when I write this, what I can have is, it's a u is equals to g by 2 into bracket t1 plus t2. I know that h max is equals to u square by 2g. So let's replace the value. It's a 1 by 2g multiplied by a square of the u. It's a g square by 4 into bracket t1 plus t2 whole square. This is 2g, this is 4. 1 of the g can be cut it down, and 2 4s are 8. So this is g by 8 into bracket t1 plus t2 whole square. I hope these things are clear to you. Is it clear? Can it be done by you? Can it? Are you sure? Okay. So one more thing. If they ask that, find out. Let's, in the previous question, find the value of height h. This was the situation. This was the time t1. This was the t2. As this is the t1, even this is t1. So what we have derived in our classes was that this h should be is equals to half into g multiplied by t1 into t2. You must remember this. This would be the answer. This has been asked twice in the medical examinations. So there could be a probability to be asked. So this is h, and that should be is equals to 1 by 2 into g into t1 into t2. I hope these things are clear. Is it? Yes? Can it be done? Are you sure? Okay, let's move to the next question. What they have provided. Look at this very carefully. What they have given is an object moving with a speed of 6.25 meter per second is decelerated at a rate given by dv by dt. That's an acceleration is given, which is minus of 2.5 under root of velocity, where v is the instantaneous speed. Okay, the time taken by an object to come to the rest. I require a time taken by an object to come to rest. A rest, that means its final velocity should be a 0. So what I can have is, it's an a which is given as minus of 2.5 under root of v. So acceleration is given, so let's write it as a dv by dt. I have a two options. A should be is equals to dv by dt, and the one more option would be a is equals to v dv by dx. Now which one to choose? As I have been asked time taken, this is most preferred, because here I can reach up to the distance, but I cannot reach by the time. So what I required is time. So I have selected this. A is equals to dv by dt. So this dv by dt is equals to minus of 2.5 under root of v. Let's solve this. It's a dv by root v should be is equals to minus of 2.5 into dt. Integrate this from where? from initial velocity is 6.25 meter per second to finally it comes to rest, it would be a 0. So when velocity is 6.25, as it is an initial velocity, my limit would be a 0 and velocity would be a 0 at time t. So this is the situation. If I integrate this, this is equals to 2 root of v from 6.25 to 0. This is equals to minus of 2.5 into t to the 0. Let's put up the value, and if I solve this, it would be a time is equals to 2 seconds. It would be a time of 2 seconds, that within t is equals to 2 seconds this will happen. I hope these things are clear to you. Yes, and this can be done. Is it? Can it be done? Are you sure? Can it be done by you guys? Are you sure for this? Yes. Let's move to the next question. What they have given is that velocity of a particle is v is equals to v naught plus gt minus f t square. If its position is at x equals to 0, at t equals to 0, then its displacement after unit time, that means t is equals to 1. What can I do? I have been provided with the velocity, which is v is equals to v naught plus gt minus of f into t square. What I require is I require a displacement. How can I do this? And what are the possible options? Yes, you are at velocity, and what do you require? You require a displacement. So shall you move further or backward? Yes, you are going to move a backward. For backward, what do you require? You require differentiation or you require integration? Yes, you require an integration. So let's integrate this. We have this relation v is equals to dx by dt. From this we are having dx is equals to v dt, and from this I can write like this: x is equals to integration of v dt. I hope you remember this. So this should be is equals to x is equals to integration of v dt, that is equals to v naught plus gt minus of f t square dt. So that should be is equals to v naught t plus gt square by 2 minus of f into t cube divided by 3. I need to put a limit from 0 time to time t is equals to 1. So this is to be integrated from 0 to 1. So if I write this, if I put up a value of this, then x, let me write one more thing, it's a v naught t plus gt square by 2 minus of f naught into t cube divided by 3, beginning from the 0 ending on the 1. So it's v naught plus g by 2 minus of f by 3 minus of, if I put a 0, it would be an 0 itself. So the final answer would be a v naught plus g by 2 minus of f by 3. Displacement, this is meter, and this would be your answer. What was your answer? Is it same? Is it? Great. So I hope these things are clear to you and ready for the next question. What the data has given. Look at this carefully. A particle located at x equals to 0 at time t is equals to 0 starts moving along the positive x direction with a velocity v that varies as v is equals to alpha into root x. And what you require is the displacement varies with time s. Okay, so what can you do? What they have given is v is equals to alpha root of x. Now I can write that velocity, it is equals to dx by dt, that is equals to alpha into root x. And if I can write this, I can also have a relation of dx by root of x should be is equals to alpha into dt. This is x to the power half, so if I write, it's an x to the power minus of half, into dx is equals to alpha into dt. Let me integrate on both the sides. If I integrate both the sides, it would be an x to the power minus of half plus 1 divide by minus of half plus 1 should be is equals to alpha into t. Yes, so x to the power minus half plus 1, it would be an x to the power plus half divide by plus half should be is equals to alpha into t. So this is 2 into x to the power half, it's a root of x, is equals to alpha into t. So if I square this, it's a 4 into x should be is equals to alpha into t square. If I require only the displacement in terms of the time, I can write like this, x directly proportional to the t square, and this would be the answer. I hope these things are clear to you. Is it? Do you have a same answer? Do you? Ready for the next question? Ready? Are you sure? Let's move on to it quickly. What they said is a ball of mass m1 and another ball of mass m2 are dropped from equal heights. If the time taken by the balls, the time taken are by the balls are t1 and t2 respectively, then now two balls are there, both are having a different mass, but they have been dropped from a equal height, and you require to find out the time taken by this two. Yes, so let's do it. Let's say this is height h, and from this side two balls are going to be dropped, that they are going to be dropped from u is equals to 0, and probably a first ball take a time t1, another ball take a time t2. So what I can have is that h is equals to ut plus half gt square. Now in my case u is equals to 0, so this would be equals to half into g into t square. If I write this, what I can have is t square should be is equals to 2h by g, and if it is the case, this t should be equals to root of 2h by g. So if I look at this relation very carefully, what I can get is that time of flight, or this time required, is dependent on root of h, as we consider that g is a constant at this place. So this does not depend on the mass. This does not depend on the mass, and when it is not depending on the mass, I can say that t1 must be is equals to t2. Yes, t1 must be equals to t2. Are you done with this? Yes, are you done with this? Yes. Let me add something to this. Let's say when this ball will be available at this point, and this ball will be available at this point, this is the v1 and this is the v2. You need to find out the ratio of v1 is to v2. This is additive from my set. So what I can have is that v square equals to u square plus 2gh. As u is 0, what I can have is v should be is equals to root of 2 into g into h. As my g is a constant, v is directly proportional to the h. Both the objects have been dropped from a same height, so v1 is to v2 should be equals to 1. Yes, even this velocity does not depend on mass. Time does not depend on the mass. Yes, I hope these things are clear to you. Shall I add one more and last question to this? Shall I? Can I add this? Yes. This will be done by you guys. Find out kinetic energy 1 by kinetic energy 2 at the bottommost point, at the bottom point. This is required, and basically I want that you people please observe that does it depend on mass or not. Yes, so that is to be done by you guys. Please do it. And let's at this point of time move to the next question. This is very good question. Do this with more patience. What they ask is that a relation between time t and distance x is given, and that relation is t is equals to ax square plus bx. They have provided us that a and b are the constant. What we require an acceleration. So we are at distance x and time t, and we need to go up to the acceleration. So the thing should be look like this. It's an x. If we differentiate it once, it would be an v, and if we differentiate it one more time, or from the distance, it would be a differentiation of two times. It would be an x to v and v to a kind of journey would be there. And if we can do it, yes, our task would be done. So let's begin. What I am having is t is equals to ax square plus bx. Let's differentiating it with respect to time. So it's a d by dt of t that should be is equals to d by dt of ax square. So this is 2ax into dx by dt plus b into dx by dt. I hope these things are clear to you. Yes, so this dt by dt is equals to 1. This is dx by dt. What do we call? It's a v. So dx by dt, it's a v. It's a 2ax into v plus b into v. So this is v is equals to 1 by 2ax plus b. Now this is just the velocity. And you need to reach up to the acceleration. So let's differentiate this. With respect to time one more time. So I'm differentiating it, and this would be is equals to, this can be written as 2ax plus b to the power minus of 1. I hope these things are clear to you. If I differentiate this, then it would be a minus of 1 into 2ax plus b to the power minus 2. This is it. Multiplied by I need to differentiate it one more time. It's a 2a. So if I solve this, what I can have is it's a minus of 2 into a into v cube. I hope these things are clear. Yes? Are you? Can it be done by you guys? Are you sure? Let's move to the next question very quickly. What the data has given. Look at this. What the data has given. They said that coordinates of a moving particle at any time t are given as x equals to alpha t cube and y is equals to beta t cube. What you require? You require the speed of the particle at time t. Yes. When it has given that these are the coordinates and it is moving in x as well as it is moving in y. So this is x is equals to alpha t cube. The situation should look something like this. This is x. This is y. So x is equals to alpha t cube, and if I differentiate this, because I require a speed, so vx it's equals to 3 alpha t square, and I can say this is vx. I am provided that y is equals to beta into t cube, and if I differentiate this, it would be a 3 beta t square. It's a vy. So one of the velocity is in x direction, one of the velocity is in y direction. What I can have, I required a velocity or the speed of the particle at time t. So this is vx, this is vy. You can see this is at 90 degree. Yes. So if you plot this like this, it's a vy, and this hypotenuse would be my answer. So value of an hypotenuse would be equals to root of vx square plus vy square. So I need to find it out. This v is equals to under root of vx square plus vy square. Just replace the value of the same and find out the answer. Yes, can it be done? Great. Shall we move to the next question? Shall we? Are you ready for it? Let's go. What the data is telling, it's an acceleration A of a truck starting from the rest varies with time t according to the relation A is equals to kt plus c, where c and k, these two are the constants. The velocity v of the body after time t will be, you need to find out the velocity of a body after time t. How can you do it? How can you do it? Yes, acceleration is given and velocity is required, so you need to differentiate it or integrate it. Yes, you need to integrate this. Can you do it? Yes, we have this a is equals to dv by dt, and from this we must be knowing that dv is equals to a dt. If I know this, I also know that this is equals to an integration of a dt, and if I put up a value, it's a kt plus c dt, that would be is equals to k into t square by 2 plus ct. This is velocity. That's it. This is kt square by 2 plus ct. This would be my answer. This is the answer. Second. Yes, these are very easy questions. Very easy questions. Yes, but the problem is that we need to do this in a certain particular given time frame only. Yes, I cannot allot this questions 2 to 3 minutes. That is where the problem arises. Yes, so, and that problem, that to do a correct question, within a given time frame, you need to practice this hard, because as soon as you are moving towards the difficult lectures or difficult topics, basically if we talk about the motion or laws of motion or a rotational motion, those questions will take a more amount of time to get it solved. So these are the questions which can save a time for those tricky questions. So please practice this very hard, so time can be saved and accuracy can be improved. That is essential. So look at this question. What they said is the displacement is given, and they ask that how long, that means they require a time, does the body take to come to rest. Yes, so displacement is y is equals to minus of 2 by 3 t square plus 16t plus 2. What happens when body comes to rest? At that instant velocity equals to 0. So what I can have is, I am having displacement, I need to find out the velocity, so I just differentiate this. V is equals to dy by dt, that should be d by dt of minus of 2 by 3 t square plus 16t plus 2. So this is equals to minus of 2 by 3 multiplied by d by dt of t square, it's a 2t, plus 16t, it's a 16, and this should be a 0. If this should be a 0, this is 2 into 2, this is minus of 4 by 3t equals to minus of 16. So this 4 and 4 would be a gone, minus minus would be a plus, and t should be equals to 12 seconds. What was your answer? Is it same? Does it? Are you sure? Okay, let's move to the next question. We are just on an ending of this session, so please have a patience and calculate each and every question with me. Calculate it. This will help us to solve as many questions as possible. So let's have this question, a very intelligent question, a very good question. I like this a lot. So look at this. It's a question of probably JEE, and This is the same question. This is the same questions that has been already given in the NCRT. And maybe a very few times it may happen that the JEE ask a direct question without even changing much amount of data from the NCRT. A direct question. This is one of them. Yes. Go through this. Go through this. What they said. They said that two stones are thrown up simultaneously from the edge of a cliff 240-meter high with initial speed of 10 and 40. Which of the following graph best represents the time variation of the relative position of the second stone with respect to the first? And they said that ignore the effect of air resistance, neglect the air resistance, take g is equals to 10 meter per second square, and these are the speeds. So this is the situation. This both are having a different speeds, and they have been thrown from a certain height. That height is 240 meter. Now look at this. If you attend this according to the examinations, that what you require just a simply schematic. When I used to say schematic, that means I just work on the shapes. I don't need it exactly. So if I assume that this would be a 240-meter height, and this has been thrown, this probably first object, this would be the second object, both are having an initial velocity that would be a different. So if I write this, h1 is equals to u1 into t1 plus half into gt1 square. Yes. And h2 is equals to u2 into t2 plus half into g into t2 square. Yes. So if I solve this, this is a very bigger approach. H1, that put up a value of everything and just try to solve this, that within how much time this will again landed up on the ground. A same thing is true for both the cases. But if I go with the relative velocity, this might help. Let's look that if I go for the relative velocity, one of them has been thrown for the 40, another one has been thrown for the 10. So their relative velocity would be equals to 40 minus 10, it would be a 30. And y2 minus y1, separation between these two, because both have been traveling with half gt square. So their a relative would be equals to half gt square minus of half gt square, and that would be a 0. So if I write like this, it's a y2 minus y1, that would be equals to their velocity multiplied by time. It's a 30 into t. So before both the stones reach to the ground, it should be a straight line, something like this, something like this, something like this, something like this. But problem arises that every options given have a same situation. But if you look at this carefully, that a second stone has been thrown with 40, and this stone has been thrown with the 10. So there must be difference between both the stones, that both the stones are not on a ground at same time. One of them would be at certain height and another would be at the ground. So if I understand this situation, one of them would be at a ground, so their h1 would be equals to 0, let's say, and this h2 must be on travel, u2 t2 plus half gt square. So if I take a difference of this two, this should be look like this, and my previous situation was something like this. So let's try to match this. It's an answer number 3. Yes, so this would be the final answer. I hope these things are clear. Yes, so let's wind it out here. Yes, this is the last question. This is the last session of motion in a straight line. But motion in a straight line is not limited to this. Please do as many questions as possible, because this will help us. Thank you. Have a good day. Take care. Bye bye.